So normal distribution is the most important chapter in S1, and any data which are symmetrical, like if you're dealing with symmetrical data, in that case you can use normal distribution. Thing is, the y-axis, as in the heights of this graph, actually represents the frequency, and the area under the graph represents probability. Just like in histogram, area gives you frequency, in normal distribution the area under the graph will give you the probability. So since total probability is actually 1, right? So like I said, it's symmetrical, right? So if you are actually dividing this whole thing, in that case we have 0.5 and 0.5 on both sides, right? So area under the graph represents the probability. So suppose you have this value as 3, and you need to know the value of the probability that the value will be less than 3. So for that you need to calculate this area, which is the shaded area, left side of 3. So instead of calculating this area, what we can do, we can get the value of this area directly from the table. Okay, directly from the table. For each value of z represents the standard variable here. Okay, so the table is actually given for different values of z. As you can see here, we have different values of z. Suppose z is 0.5, z is 1, z is 1.55. So for different values of z, you have a different probability values, right? So for each value of z, you will get a corresponding probability that will be the value for the area under the graph. So suppose I need the value for the probability that z will be less than 3, or suppose z will be less than 2. Okay, so z is less than 2. So it means I'm talking about this section, right, this area. So you can get that value directly from the table. Okay, suppose z is less than 2, you can get the value directly from the table. For 2, when z is 2, the probability is this. Okay, 0.9772. 0.9772. Similarly, if you need a value that z is actually less than 2.1, z is less than 2.1, so for 2.1 you can see the corresponding probability is 0.9821. Okay, so this table actually gives you value of the area which is less than that specific z. Okay, less than that specific z. So sometimes if you need the area for greater than, in that case you can do 1 minus the shaded area, right? Because this table will always give you value for area which is at the left side, as in the less than side. Okay, so for greater than side you can actually manipulate the data and calculate the value, since we know that the total area will be 1, because area represents the probability. So if we look at the table, we have different values of z, and for each values of z we have a probability, right? And as you can see, this actually gives you less than, z less than, z less than. So each and every single probabilities here are actually is actually for less than value. Okay, and this is actually represented by phi, this sign. So suppose if I'm talking about z less than 2, it means I'm actually taking this area, right? Value of that is 0.9772, but you can also represent it as phi of 2. Phi of 2 means this area less than 2. So this is actually 0.9772. You can directly write the answer, but then again, for some statement purpose, if you use phi of 2, in that case it will be easier to use the formula. Okay, so instead of directly picking the value from the table, I will mention it as phi of 2. Phi of 2 means area less than 2, basically probability less than 2. So if I need z less than 3, it means I will just search the value for 3, z equals to 3. As you can see, this is the column for z, right? The first column is for z, and then the second one is for the probability. So z less than 3 is this one, but I can write it as phi of 3. And then phi of 3 means z is 3. What is the probability? What is the probability? Probability is 0.9987. Okay, so basically we can get different values of probability from this table. So the thing is, for solving math from this chapter, you can actually go two ways: by drawing this thing, or you can use the formulas. So the easier way is to use the formula. So instead of using a or x, I am using a numerical value 3 so that it's easier for you to understand. So these are the 4 formulas that we will be using to solve this chapter. So z less than 3 means phi of 3. Like I said, the last example I have shown, if this is 3, z less than 3 means this area, which is represented as phi of 3. And value of phi of 3 is what? Value of phi of 3 is z is 3, and that corresponding probability value is your phi of 3. So phi of 3 is from the table. You can take the value for phi of 3 from this probability column. And if you analyze the data of the table, you can see all the values of z are positive, right? All the values of z are positive. But what if I need to work with negative values? This is 0 if z is 3, but what if z is minus 3, right? So we have some problem here that the table actually gives you some selected values, right? It's not unlimited. As you can see, z starts from 0, and what's the maximum value of z? 4. Okay, so the table is given for selected values of z, and like I said, it's for positive values of z. So that you can find only positive values. Okay, and then it's always for less than. Okay, so less than and positive, these are the two criterias if you need to pick the values from the table. But sometimes we might need values for greater than, sometimes we might need negative values. So what can we do for them, right? So that's why we need to use those 4 formulas, because the first one, positive and less than, this is from the table, but using that we can find the other values. Okay, so let me just explain the derivation of the formulas so that you can go both ways, using formulas, or you can also draw the diagram to solve the math. I will show both the processes. Okay, so let's start with the very first one. Suppose this is 3. In that case, z less than 3 is this space, right? So z less than 3 is this space. So probability of z less than 3 is actually phi of 3, as in this space, left side of 3. And value of that, we can find out that value from the table, as in where z is 3, you just pick that probability. That's actually phi of 3. So if we go to the table and find z equals 3, so probability is 0.9987. So the answer will be 0.9987. So I'm just using an example with 3, but if you need different values, suppose you need 2.5, you will take the value for corresponding value for 2.5. That's it. So let's move to the next one, the second one. 3, and phi of 3 is what? This left side. This left side is actually phi of 3. But sometimes we might need value which is at the right side, as in z greater than 3. Instead of less than, we can sometimes we need to find z greater than 3. But like I said, the table is for less than values, right? So if you need greater than 3, in that case what you can do, you need this area, right? So the total area is 1. So if you just deduct this left side, that's 1 minus phi of 3, you will get this greater than area, right? So z greater than 3 is 1 minus phi of 3. And phi of 3 is what? Phi of 3 is the value from the table that we got, like this one. So 1 minus phi of 3 is Z3, and that corresponding probability value 0.9987. So if you solve this, you will get the result for greater than Z. Z greater than 3. Okay, so now we need to work with negative values. So suppose this is the origin, this is 0, this is 3, but we need minus 3. Suppose we need minus 3 and we need this area, as in Z less than minus 3. Okay, so we need this portion, Z less than minus 3. And the thing is, we are working with symmetrical data, right? So if we are working with symmetrical data, it means if this is 0, this is 2, this is minus 2, in that case 0 to positive 2 will be equal to 0 to negative 2, right? Similarly, if we need greater than 2, that will be equal to less than negative 2, right? Since it's symmetrical, this blue portion and this blue portion will be equal to each other, right? This area and these two zones are equal, since we are working with symmetrical data. So that's why this less than minus 3 is actually equal to what? Is actually equal to greater than positive 3. And if we look at the previous example I have just shown here, this is phi of 3, but that portion was 1 minus phi of 3, right? So this is actually this part, right? 1 minus phi of 3, and this 2 portion has to be equal. So that's also 1 minus phi of 3. So if we need Z less than minus 3, we cannot get this value from the table because the table is actually for positive Z, but Z less than minus 3 is basically equal to this part, which is probability of Z greater than 3, right? So the value of which is 1 minus phi of 3. So that's 1 minus phi of 3. Then you can just substitute the value. Phi of 3, we know the value for phi of 3, right? 0.9987. Suppose you need, sorry, this is minus 3. Suppose you need this area. Okay, so first of all, let me just show you the shortcut method. If Z is actually greater than minus 3, what you can do, you can just reverse this sign. Like if you actually use, instead of greater, if you just use the opposite sign, in that case negative will be positive. So Z less than 3. So you can switch this simultaneously. Switching this less than will convert this negative sign into positive. So Z less than 3 means we are back to the same starting point, which is phi of 3. Okay, and if you need to actually understand using this area thing, in that case, if I draw this graph, this is positive. In that case, this is phi of 3, right? So since this is symmetrical, like I said, since this is symmetrical, you can understand that Z less than 3 is this greater portion, right? And here if you're working with negative 3, so this is the greater portion. Okay, and if you actually need to solve in detailed version, like the derivation, if Z is greater than minus 3, first of all, for any greater than thing, we need to use a minus sign. We need to use 1 minus phi, right? So 1 minus phi of minus 3. And for any negative, we also need to use 1 minus phi. So this is 1 minus phi. So if you simplify this, we will get phi of 3. So instead of using this thing, we can directly just convert the sign. That's it. Okay, so if I summarize this whole thing, this is the complete derivation of the formulas. But like I said, to solve the math, you do not need to go for the derivation. You can use the formula directly. But to make things easier, I have discussed the derivation. So now I will just summarize this whole thing. As in these four formulas are what we need to solve the math. So if you have, remember the table is for positive values of z, and it will give us area less than. Okay, so if this is 3, we are getting less than area. Okay, so z less than 3 means this area, which is phi of 3. Phi of 3 means the probability for z equals to 3. So if z is 3, the probability you will get here, that's actually phi of 3. So we should not have any problem understanding the first one. Z less than 3 is phi of 3, the value which we get from the table. And if we need greater than, the table is for less than, right? So if we need greater than, we can just do this thing, 1 minus phi. Why? I have explained this here. Because it gives you the area at the right side. So 1 minus should give you this area, since total area is 1. Okay, so if we need greater than thing, you just use this formula, 1 minus phi. If you need negative value, less than negative value, since it's for positive, if you need negative value, you need to use 1 minus phi. Okay, so the thing is, if you have positive less than, you can directly use phi. If you have negative, you do 1 minus. If you have greater than, you do 1 minus. And the last one is z greater and negative, as in opposite to both this situation. You can just reverse the sign, z less than 3, and then that's phi of 3, the first line. Okay, so these are the 4 formulas that we will be using to solve this chapter. You can solve each and every single math by drawing the diagrams. You can solve this using diagrams and the detailed version, but using formulas will make this short and easier. Okay, so let's solve one math. Suppose this is number 1. We need to calculate these values using the table. Okay, so the first one says that less than 2.2. So less than positive value. So the table is for positive and less than, right? So we do not have any problem regarding this. So this should be equal to phi of 2.12. And what is phi of 2.12? That's actually when z is 2.12, you just pick the probability. That's actually phi of 2.12. Okay, so if I go there, 2.12, here it is. So the value is 0.9830. 0.9830. So we are done with this part A. Next we have z less than this. So that's phi of 1.36. So z is 1.36. So z is 1.36. This one. So the probability is 0.9131. Okay, so the next one is greater than. So for greater than, we do not have value from the table, so we will do 1 minus phi of this value. So 0.84. So 0.7995 is the probability. So 0.7995. So if you solve this, you'll get the result. Then we have negative value, but the table is for positive. So whenever we have greater, we do 1 minus 5. Whenever we have negative, we do 1 minus 5. Okay, so that's 1 minus 5 of 0.38. For negative sign, we are actually doing this 1 minus 5 thing. So 0.38. So probability is 0.6480. Yes. Okay, so that's it. So using this 4 formula, we can actually solve this. Apart from that, you need another thing. If the value is given within range, then suppose we need to find value between 2 and 3. this part only. Okay, so they will ask you a question like, what is the probability for z greater than 2 but less than 3? So as an in between this two part, right? So what we can do is, if you analyze the situation, if you find area less than 3, that's the total red part, right? This entire thing, which is actually phi of 3. Phi of 3 will give you this total area. Okay, and if you actually find less than 2, you will get this green portion, right? So if you actually deduct this entire phi of 3 is the total area, right? The red portion. If you deduct the green portion from the red, in that case you will get this in between area. So basically you are finding phi of 3 first to get the total area, then you are finding phi of 2, then you are deducting them to get the in between area. So it's basically phi of 3 minus phi of 2. So whenever you get value from in between range, you just use phi of this greater value, as in right side, minus phi of this lower limit, lower value. Okay, so for example, this one, we have to find this z greater than 1.25, less than 2.16, right? So we can find phi of this greater value minus phi of this one, and then you can find the value from the table. Phi of 2.16, it means z is 2.16. 2.16, this one. So probability is 0.9846, and phi of 1.25, so 0.8944. So solving this will give you this final line. For this one, it will be phi of this greater value at the right side minus phi of a value which is at the left side, and phi of 2.38 is something we can find from the table, but since we have a negative sign, so in that case we have to use 1 minus phi, because the table won't give you any negative value of z. So minus 1 minus minus will give us plus. So we just pick this value from the table. We will just select values for this. So 2.38 is the value for z, 2.38. So 0.9913 minus 1 and plus this 1.67. So 0.9525. So solving this from the calculator, you will get the final result. Next we have this. So it will be phi of this right side 0.85 minus phi of this value, the lower limit, 2.16. But for negative we need to use 1 minus phi of 0.85, right? And for this also we need 1 minus phi of positive. So if we simplify this, 1 minus phi of 0.85 minus 1, minus minus will give us plus phi of 2.16. So 0.85, this one, so 0.8023. This minus sign is here. Value of this is actually 0.8023 and 2.16, 0.9846. So if you simplify this, you'll get the result. For this one, it will be phi of 1.57, that is the value at the right side, minus phi of the value at the left side, minus 1.57. So phi of 1.57 minus, for negative 1 you need to take 1 minus phi. Minus then plus 0. Phi of 1.57. So 1.57 is your value for Z, and probability is 0.9418. So solving this will give you the final result. So basically this is the derivation of the formula, and these are the 4 formula that we have used to solve the math. For Z positive value, less than positive value, you will get phi of 3 or phi of 4, phi of 2, whatever the value is. I'm just showing this formula with a numerical value 3. So if you have greater than sign, you need to use 1 minus 5. If you have negative sign, you need to use 1 minus 5. If you have greater and negative, in that case you can just reverse the sign and go back to the original line. That's it. So that's the basic of this chapter. Okay, so in this one we need to find the value of A, and probability is already given. Like probability of Z less than A equals to this. So probability of Z less than A, we can replace that with phi of A, right? We can replace that with phi of A, just like this one. If Z is less than 3, we can write it as phi of 3. And phi of 3 is what? Phi of 3 is Z is 3, and the probability we get from the table for Z equals to 3 is actually phi of 3. So basically phi of Z, a value of Z, is the probability. So in today's class we will do the opposite. Like we have the value for probability 0.9082, 0.9082, 0.9082. So for 0.9082 probability Z is actually 1.33. So it's like phi of 1.33 is this probability, right? So now that we know the value of this probability, we can replace that with phi of 1.33. So we know the probability, right? P equals to this. So this is the value of probability. So we need to find that probability in this table and then pick that corresponding Z. So phi of 1.33. So if you just compare both sides of the equation, phi of A, and at the right side we have phi of 1.33. So comparing just the position, we can say that A is 1.33. So you can imagine that we are just cancelling out phi. We are not. We are just comparing that phi of A and phi of 1.33. So if you just look at the position, then A is 1.33. Next we have probability of Z greater than A. Sorry, so probability of Z greater than A. So for greater than, we use 1 minus phi, right? So 1 minus phi of A. And then if you just subtract phi of A from this equation, we shift 1 at the right side. So we will get 0.9686. So basically we have minus phi of A at the left side, and when you shift 1 here, minus 1, we will get minus 0.96. So if you cancel out minus from both sides, we are left with this line. So in short, you just subtract phi of A from this equation, you will get this value. So phi of A equals this 0.9686. So this is a value for probability, right? 0.9686. 0.9686. this one 0.9686, so we will just pick the z, so that's 1.86. so we will write phi of 1.86. so phi of a and phi of 1.86. so if you compare, we get the value for a. So next is part C. Okay, so for part C we have probability z less than a, so that's actually phi of a, and we have 0.3372. so the problem in this math is the probability is 0.3372, but if we look at the table, the value of probability actually starts from 0.5 in this table, right? 0.5, and the maximum value here is 1. So we have a very limited values of probability, so we need to start from 0.5. But now that we have 0.3, which is not available at the table, so what we can do, we can actually just, it's just that if you have a value 0.6 which is greater than 5, and then the alternate value is 0.4, right? So if you do not have 0.4 in the table, it means you will definitely have 0.6 because it's greater than 0.5. In short, if you do not have any value at the table, in that case, if you just deduct this value from 1, whatever you get, that will be available at the table. So I will just use 1 minus on both sides, 1 minus phi of a and 1 minus this thing. So at the right side we will get 1 minus 0.3372, that will be 0.6628, right? You deducted this from 1, so obviously this will be greater than 5.5. so 0.6628, 0.6628. So the value is 0.42. So this will be phi of 0.42. So the thing is, we actually get the phi at the right side, but at the left side we have phi 1 minus phi of a. So if we keep this like in this format, 1 minus phi, but we have phi, we cannot compare the coefficient thing, right? We cannot compare the position. So that's why we want only phi of something, not 1 minus phi. So the point is, if you have phi of minus 3, in that case we write 1 minus phi of positive 3, right? For any negative value we use 1 minus phi. So if we have 1 minus phi of 3, we can replace that with phi of minus 3. As in, if you just use 1 minus phi, the signs are opposite, right? At the right side and the left side the signs will be opposite. So 1 minus phi of a, if you just want to write phi of something, we can write phi of minus a. So in that case, we have phi of something and phi of something only, and if you just compare the position, we get minus a equals this 0.42, and from here we will get the value for a, minus 0.42. So this is part C. Next we have part D. So in this one we have 1 minus phi z greater than this, right? So for greater than, we use 1 minus phi, and at the right side it's 0.6, it's greater than 0.5, so we will definitely get this value from the table, 0.6879. 0.6879. So the value is 0.4, z is 0.49. So z is 0.49, and we already have phi of something at the right side, so that's why we want only phi of something. Instead of 1 minus phi, we want only phi of something. So like I said, 1 minus phi of 3 is what? Phi of minus 3, right? So 1 minus phi of a we can replace that with phi of minus a. And now if we just compare phi of something, in that case minus a will be 0.49. So this will give us the value for a, which is minus 0.49. Next, what if we have things in range, like in this one? So in this one, if we have the values in range, in that case it's phi of the upper limit, upper value, and then phi of the lower value, because it's just that if you need to find the probability between 2 and 3, what you can do, you can just find the phi of 3, which will give us the total area, which is less than 3, and then phi of 2. So if you deduct them, we get the in-between area. So this is actually phi of the upper value, the greater one, a, minus phi of 0. So phi of a minus phi of 0 at the left side. Then phi of a will be here, but phi of 0, so z is 0. Phi of 0 means z is 0. What is the value for the probability? So z0 value is 0.5. Probability is 0.5. So 0.3354. So if we just shift this at the right side, this will be added to this value, so we will get 0.5354. So this is 0.5354. we need to select that from the table. 5354. 0.53 5354. Okay, so we do not have 5354. If we do not have any value from the table, in that case we have to use interpolation. Like, the thing is, this is actually 19 and this is actually 59, but we want 0.5354, as in we want value somewhere at this point, 0.5354, as in 54. So for that, you can actually, the shortcut is, for the time being we can just select the value which is closer, like this one is closer to 0.5354, so we can pick 0.09. But to be more accurate, you can use interpolation, like from 19 to 59, the gap is you can just use shortcut to find this. The difference is 40, right? You can use the difference like 0.0040, as in we can consider the decimal place, but I'm just using shortcut. Like, this is 19 and 59, so the difference is 40. Okay, so for this difference, for a difference of 40, this value of z increased by only 0.01, right? 0.08 to 0.09, so the value just increased by this. For a gap of 40, this increased by 0.01, but we want a value somewhere over 54, right? 0.5354. So the difference will be 54 minus 19, it's 35. So we want the value for 35 only. So for 40 gap, it's the increase is 0.01 for 1, and for 35. The difference will be 0.01 by 40 into 35. So the difference, whatever the difference is, you just add that difference with 0.08 to get that value. So if we add this difference with 0.08, we get 0.08875. Okay, so if you round it up, it's 0.089. Okay, or let's take the entire thing, so 0.08875. so it's phi of 0.08875. Okay, next is that for any variable, uh, we have to we can use that table only if the value are standard value, as in this value we get are only z. But for any value which is suppose x or any other variable, suppose y, we cannot get values from the table, right? The table is limited for a certain range of values, like z has to be between 0 to 4, right? So if we need values like x is less than 33, so it's supposed to be phi of 33, right? But we do not have value of 33 in the table. So for any random variable we need to convert them into the standard variable z. Only then we can actually get the value from the table. So for any variable, if you need to convert them into z, this is the formula. Like whatever your value is, suppose your value is x, so x minus mean divided by standard deviation. Okay, and mean is represented by mu and standard deviation is represented by sigma. So to convert any value into z, this is the formula: x minus mu by sigma. So suppose in this one, and the value is given like this, like x and then 30 and 2 square. 30 is the mean, and the value next to it will be the variance. Variance is what? Variance is sigma square, right? But we need the value for sigma only, so sigma square is given 2 square, so it means sigma is 2 in this math. So if we need to solve this, x less than 33, we cannot get value from the table, we need to convert that into z first. So if that's z, in that case it's 33 minus what? Mean and sigma, mean and standard deviation. Mean is 30, standard deviation is 2, so we get z less than 3 by 2, which is 1.5. so z less than 1.5 means z less than 1.5 means it's basically phi of 1.5, right? So phi of 1.5 means value of z is 1.5. We will just pick the probability. For 1.5, probability is 0.9332. Okay, so suppose this one, in this one the variable is y and mean is 25, so mu is 25, and this is actually the variance. It means this is actually sigma square. Sigma square is given here. Sigma square is 25, so it means sigma is basically 5. And to convert that into z, this is the formula: x minus mu by sigma. Okay, so let's solve part A. So we have the variable y here, but we do not get values for y. We will get only z from the table, so we have to convert this into z. So if I write z instead of y, in that case I have to convert this data into z using this formula. X is just an example, so in our case it's y, so this is y minus mu. So y is 20, so 20 minus mu is 25, and sigma, which is the standard deviation, is 5. So z less than minus 1, so this will be 1 minus phi of positive 1. Means z is 1. What is the probability, right? So z is 1. This is it. So probability is 0.8413. So it's similar to the thing we do in range, but at first we need to convert them into z, right? So let's convert them into z. So instead of writing y, I will use z here. So that's why this 26 will be 26 minus mean by sigma. Then this 18 will be 18 minus mean by sigma. phi of this 0.2 minus phi of this minus 1.4. So since this is minus, we need to use 1 minus phi. So this will be 1 minus phi of 1.4. And now we can just pick values from the table for phi of 0.2, and then that's minus will give us plus. So from the table we will just pick values for this two, and then we can just add them up or simplify to get the final result.